So my name is Romanyak. I'm a network engineer at Squarespace. And I will be talking about impact of network automation at Squarespace. And for those who may not be familiar, Squarespace is the platform for millions of people and businesses to create easy-to-use and stylish online presence. In this talk, I'm going to give a quick overview of network architecture at Squarespace. And then I'm going to present a couple of use cases, how and where we apply network automation. I will also show how we use route servers for traffic manipulations and traffic engineering, and show how we do monitoring. In this talk, I will be referring to routing, network routing, dynamic routing protocol, specifically BGP. So I'd like to go over few terms for those who may not be familiar to get everybody on the same page. So BGP is a routing protocol for routing between autonomous systems. And autonomous system is the collection of networks under the same admin domain with a single routing policy. Autonomous system number is the number that is assigned to autonomous system. And there are globally unique numbers, and there are private numbers that are used in internal networks. BGP neighborship or peering is the relationship between two systems that talk BGP. The session runs over TCP port 179. And there are two types of BGP peering, iBGP and eBGP. iBGP is peering between systems in the same autonomous system, and eBGP peering is the peering between systems in different autonomous systems. So when we peer with the ISP, it's eBGP peering because it's two different autonomous systems. BGP has attributes. BGP route has attributes. And when the router receives a set of BGP routes it receives from somewhere, it needs to select the best route. It does it by running BGP algorithm and comparing route attributes. One of the most important ones is autonomous system path. It's a well-known mandatory attribute, and when the route is propagated through the network through different autonomous system, the ASN is recorded into that route attribute. BGP community is optional transitive attribute, and it consists the format consists of two parts. It's a 32-bit value split in two parts. First part is autonomous system number, and the second is arbitrary number that usually carries some value. So when the system originates, or the router or switch originates the route and it records the BGP community in it, it usually means something for other neighbors. So this can be matched in the policy and some action may be taken. The route server is the networking device that is usually passive. It doesn't participate in routing, and it carries all routing tables from all the devices it's peering with. So back to network architecture. In 2012 and before, we had a very minimalistic network. It was just a simple switch, a pair of load balancers with directly connected links from ISPs, and one VLAN. And that was the default VLAN. It was selected because it was by default configured on the switch. And in 2013, we started working on multi-data center environment and redundant network. And that project was given the highest priority, especially when Hurricane Sandy hit New York, and we were running out of single data center, which was in the flood zone in lower Manhattan. So we basically had to carry fuel in buckets to the top of the building to keep the generator running. So we didn't go down, actually, because of that. But after that, we started building another data center, and soon we moved out of that data center in Manhattan. So now we have two data centers in not flooded zones, not flooding zones. It took us a couple of years and a couple of architecture iterations to get to the state where we are right now. And we, for example, we used other protocols than we use currently. We use OSPF in internal routing, and we use layer 2 networks with big core switches. We don't have it anymore. And it's worth mentioning the fact that in 2015, we also moved to the new office. So we had to build a new network from scratch. And we used that opportunity to build a set of automation tools that we would later use in production. It was like kind of proof of concept. Normally, we don't run production services out of Office Network, obviously. So this Office Network was built on layer 3 only, without layer 2 links between the switches, which meant that we had to have a lot of VLANs, a lot of DHCP pools, many different network policies, and that wasn't easy to do manually. So it was basically proof of concept that we built and created documentation and tools. We outsourced it. We trained our IT staff. We showed them how to use it, and it's basically running without any problems and outages. So in production, we started using automation from low-risk tasks, but from things that had very high impact in terms of how much time it was saving. We use Ansible to automate network because partially because our SRE engineers use it for server automation, but also because it has a very good support for networking. So we started from low-risk problems and then moved to the more complex ones. And we also learned how to use developer tools, peer reviews, things like that. We automated things like syslog, SNMP, authentication, DNS, BGP community. All these things had a similar configuration template on all devices, so it was pretty easy to automate. So we developed a workflow that basically consisted of building the template for the configuration part that's being automated in Jinja 2, then running the actual playbook to build the configuration on the network management server, then run the deploy script to push the config in a diff mode, and then if the diff looked fine, we would push it to the switch or router, or the set of switches or routers. The first use case that I'm going to talk about is firewall configuration automation. And there are a couple of reasons why we wanted to do that. It was extremely important to have the same rule configured on all related firewalls. We didn't want, if we had discrepancies, it wasn't right, and it would open some security holes. We also wanted to involve people that are not firewall configuration experts, people from security team and other engineers to contribute and to build rules themselves, as well to approve them. So we automated firewall by automating different parts of the firewall configuration. Address book, it's the part of the configuration where source and destination addresses are stored. And so that was synced up with Ansible inventory file. Inventory file is the single source of truth for us. So it was a natural thing to do. So every time Ansible inventory file is changing, the automated job is running to update inventory on all firewalls across the board. Application set is where applications are listed that are also referred in the rules. And rules themselves are kept in YAML files in the format from zone to zone. And when when the rule is added to the system, we have to find it from zone to zone, and then put the rule in the zone, and then do the usual stuff. Build the rule locally, generate diffs, review diffs, and then push it to production. So it was good, but it wasn't good enough, because last two steps, when you send the PR, and then you have to still run these manual automated steps, it was still taking time, and it was a point of congestion. So we used Bamboo. It's a CI/CD tool to run the job. When the PR is sent, we would just run the automated job to build the config and to push it in dry mode, generate diff files, then security engineers or someone can basically review it and click the button and push the rule to all firewalls. One of the benefits that we got by doing this automation, even the engineer who requests the rule can build the rule himself and even deploy it sometimes. So we saved a lot of time by doing that and increased security as well. The next use case, the next example is Pineleaf network. I'll give an architecture overview and how we automated that. So from the start, we were using layer 2 networks. And then at some point, we had to keep up with all of this growing application needs. And we had to move to layer 3 networks, which were more scalable, supported more bandwidth, were built with the uniform devices. Basically, we did not have any big switches with proprietary protocols. It supported east-west traffic and had leveraged ECMP, equal cost multipath. So these layer 3 subnets that we built based on layer 3 did not have any layer 2 links at all. The layer 2 domain was contained in a layer on the leaf switch, and all leaves were connected to the spines. BGP was the only routing protocol in such a network. We did not do any layer 2 overlays. We solved the IP mobility problem on a different layer. BGP was used as a routing, and specifically external BGP was used because it allowed to use the less amount of protocol features in this network. We didn't have to use route reflectors by doing eBGP. It has a great support for traffic engineering. Loop prevention is naturally built in BGP protocol. It relies on TCP, and every leaf is in a separate autonomous system. And we build these clusters. So in one data center, we can have multiple spine and leaf clusters. We can have as many as we need to. And basically, all these clusters are connected to superspine layer. Normally, in the pod, if we want to increase bandwidth, we just add more spines. So scaling horizontally to here. Doing layer 3 in the network does not give us the ability to move IPs from one rack to another one, because layer 2 is contained in the leaf. However, we can do BGP between the server and the network and use Anycast for load sharing, load balancing. This is where one IP address is advertised out of many servers, and the network is just load balancing requests across those servers. Since we introduced Anycast, we started seeing more and more engineers using Anycast for their services. Just a couple of examples here on the slide. LDAP, Kafka, Radius, Ceph, all these things you rely on Anycast. Also, a great fit for close topology is Kubernetes. We do run Kubernetes on bare metal in the data center. And because we don't have layer 2 overlays, and we don't want to have overlays in Kubernetes, we use Calico CNI. So every cube is peering over BGP with the leaf switch and is announcing unique pod subnets, service net, as sort of anycast. And yeah, the great thing about it is that it doesn't require any networking overlays, so no complexity. Keep things simple. So having this complex topology with many devices and many interconnects, it's not the environment that can be built in a manual way, but the uniformity of the topology and modularity enables programmability, and so we can introduce more automation and leverage this modularity. Spine and leaf network is fully automated, and the only thing we have to do manually is actually rack the equipment, run cables, and configure Ansible templates. There is a part of the configuration that's related to the global view, where we announce the summary routes, anycast routes, loopbacks, autonomous systems. And then there is another one where specific pods are described, where actually all the leaves and spines are listed, and as well as route servers. I mentioned the route server a couple of times. So route server is basically a server that runs BGP and can peer over BGP with the network nodes. Route server is a passive device, and it has the global view of the network. So we can use it as a big looking glass. Also, we can announce some routes. So it's not always passive. We can announce sometimes routes to the network, and these routes can change the default behavior of the network. For example, we use route servers for traffic draining when we want to route off the spine switch for maintenance. We do this using route server. We use Bird as a software to run routing on the server. Bird is very mature, has a good community, very fast, written on C, has very rich configuration language with the ability to build complex functions and filters. So on this slide, there is on the left-hand side, there's a route server piece of configuration with the peering section to the spine switch, and there is function export to spine. It's a very trivial function that has one argument. If by default it's none and it doesn't announce anything, when it's drain, it will announce the dummy route to the spine switch, and the spine switch has a pre-configured trigger. When it sees that route, it will increase metric of all the routes announced to all the neighbors, so all the neighbors will basically choose another spine to route off this spine. This is how we use, this is an example how we use route server for traffic manipulation. The next one, the next example is using route servers for edge traffic manipulation. And we are solving a couple of problems here. First is data center failover. In the past, historically, it took us a couple of hours to fail over data center. And network was one of the steps that took a long time to do. Another problem is that we are running out of data centers. We have our own transit links, ISPs. When the ISP sends a notification that the maintenance will be happening on this day, on this date, we have to route traffic off of that link beforehand, so we don't have any impact. And we use the route servers for that as well as routing off and on of DDoS. DDoS mitigation, I should say. So Squarespace is like any other autonomous system, is connected to the internet through its peers, through ISPs. We announce our public IP space to the internet, so that's how internet can reach us. In the scenario of active standby data center, for example, if we have two public routes, we achieve active standby scenario in the edge by announcing the subnets with AS path prepends from standby data center and without from the active one. And load balancers on the bottom also, the active set of load balancers is announcing routes with a better metric than the standby one. DDoS mitigation service is connected to us in the same fashion as ISPs are. So when we want to ingest inbound traffic only via DDoS mitigation service, we will be announcing our IP space over BGP to DDoS mitigation service routers. And this way, internet will learn about our routes through DDoS mitigation network. So during data center failover, when traffic flows via active data center and we do failover, we first move the load balancers, active load balancers to another data center by changing BGP metric on the routes, and then enabling announcement on the other side, and then suppressing the announcement in the active data center, that becoming standby. So in order to do that, we used to do that manually. And then we started to use Ansible to do that by creating these templates, YAML files, where we listed all the desired scenarios. And then in order to basically route off of DDoS mitigation service, we had to run Ansible playbook, referencing the file in the variable, and that playbook would go and change the configuration on the router and to achieve the desired state. It was better than manual, but it was still not good enough. So we then introduced route server in the external network in the edge. Route server would peer over IBGP with all devices in this segment, and it would also act as a traditional route reflector for the edge routers. And the route server would also support a set of functions that attach specific community to the route to trigger some action on those routers. And BGP community we use here in the following way. BGP community is the number, consists of two parts. ASN is always static, and the number is used to encode some information. In this example, the number is used to encode site, router, ISP, and action. So there is Ansible configuration file that has all the variables needed for that BGP community. So in this case, Dallas is 2, New Jersey is 3. Supported actions are suppress, prepend, default. So basically, when we originate the route on the route server to trigger some action, it will generate that route and announce it to the network with the community in the example 3996, which means 3 New Jersey data center, all routers, all ISPs, and suppress action. And the router itself is configured with a policy that will catch that BGP community and do something. So in this case, it will catch that and reject that route, so it will not announce it to the ISP. I have a recorded demo for the following scenario. We have a test server and a public looking glass in the internet. We have a VIP configured on the load balancer. And there is no connectivity between internet and that IP address because we do not announce that /24 to the internet. We will start announcing that /24 only via one ISP called Zayo, and we will also move that IP to the remote data center, and we will do it in one click. Okay. So I'm running the ping from edge router to that VIP, and it's locally connected. So we see the latency being 0.5 milliseconds. And then we run traceroute just to confirm that. Public looking glass. Public BGP looking glass is basically the route server connected to multiple networks, and it gathers information, routing information from multiple sites. So it basically has the internet view of all routes in the full view, BGP full view table. So we do show route on that route server, and we see that internet doesn't know about that network. This is the server, external server, and ping doesn't work, just to confirm that there is no connection. Now, I send the PR, pull request, to change the bird configuration to announce the /24 to only one ISP called Zayo. And I also changed the location of that VIP. Now it's going to live in the remote data center. We have a couple of checks in Bamboo. First check is just sanity check of the bird configuration. We want to make sure that the new config is correct. And the diffs between the running config and the new config. See what's being changed. And now we will click and shift traffic. Basically, it's the same thing we do to do data center failover. We will shift traffic to another data center and enable internet to that IP. So it's instantaneous. Show route on the route server will confirm that the route server sees that route. And ping, now 35 milliseconds. Between Dallas and New York, there's 35 milliseconds. Traceroute will confirm that. This command is showing what edge router is receiving from the bird route server, and we see a couple of communities here. One of them is 2239, and it matches the community code announced to Zayo, basically, by default. Another community, 2096, means do not announce to Akamai. So that IP is not going through DDoS mitigation. We use Akamai for DDoS mitigation. Now we will monitor that transit link to the ISP in Grafana, and we will generate some traffic on the external server using iperf. So we see the load increased. Before rolling back, I'll just confirm that this is what I'm announcing to Zayo. And now the rollback will happen. So we suppressed the advertisement to Zayo after rolling back. So the connection with that VIP is lost now. There's no route on public route server anymore. And monitoring confirmed all these actions. Okay, back to slides. I showed monitoring in the video. We use OpenNTI. It's a set of tools that include Grafana, InfluxDB, FluentD. We do run telemetry on all networking devices, and we send it to FluentD, which sends it to InfluxDB, and it's basically we get 2 seconds resolution on the graphs. So this is how routing off of ISP link looks like. We basically said to prepend routes to NTT. NTT is one of the ISPs. It was NTT maintenance. We routed traffic off of this PR, and this is how it looked on the monitoring. We do run monitoring for all the networking devices that we have, including Spine and Leaf. So you can imagine having multiple clusters with Spine and Leaf clusters, and in order to build these graphs manually, it would take a lot of time. So in this slide, there is an example of Ansible configuration, which builds graphs for all leaf uplinks that exist. It's leveraging Ansible group, so it will get all the leaves in the group and build this kind of graph. To summarize, I just showed a couple of examples how we applied network automation at Squarespace. We keep all configuration in the source code, and it's a single source of truth for us. We are trying to minimize CLI interaction with the network, because that's where errors and human mistakes happen. We are doing infrastructure as a code and network as a code, and we are contributing to self-service infrastructure. Thank you all very much.
So you're going to take questions?
Yes, sure.
Great. Anyone got any question? I'll bring you the mic down. Hey.
Thank you for a great presentation. I'm curious about this part with Ansible. So when your inventory change, so is it like commit in Git triggering some kind of CI/CD automation, or what's happening
exactly.
there? And the part which I like, if I follow, so when it's triggered that part, it doesn't change system, but somebody needs to approve it before it goes to implement it.
So when inventory is changing, it just updates without approval. But when the rule is added manually, there's a process, internal process, to approve the rules on firewalls.
Thank you.
Thank you.
So I noticed automation has obviously made your lives a lot easier, as it does, but it obviously probably also brings different kinds of challenges and failures. I wonder if you've got any of those that you can share, the sort of downsides, as it were, of what you've been doing. If there are.
So the challenges that we had were running something like critical when we tested it in the lab and did the POC and everything, but still when you run it for the first time in production and it can bring down the whole site, it may be scary. Yeah, so that, but also it's very helpful when we get, for example, DDoSed, and we can route on DDoS mitigation very fast, which wasn't possible before. Another change for us as a network engineers is the mind flip. Basically, no CLI. We have to make sure that what's running in the network is consistent what's actually in the code. So that's why we run cron jobs to make sure that it's in sync. If it's not, if somebody did some manual change, we get alerted, and we don't want that to happen.
Thanks for the talk. Have you already looked into or some plans for automated testing besides sanity checks for the config file, like spinning up a VM, letting them talk via BGP, or?
We haven't looked at it. It's on the radar. Yeah.
Would be interested if somebody has such things running.
On the network equipment side, does the Ansible playbook use an API on the Juniper equipment, an example, or does it use a CLI?
It's using the API. It's using the library called Python Easy, I think, if I recall the name. And it's basically using netconf to connect it. So we generate XML locally on the Linux server, network management box. And then when the config is ready, then we ship it through the netconf via Python library, basically.
So all your boxes have support for the API?
Yes. Yeah.
Okay, thanks.
Hi. If you wanted to make this vendor agnostic, how would you, seems a very Juniper-orientated process. If you had Cisco's or other brand in there, how would you go about doing that? This is also one of the things that we will do very soon. And there are libraries that allow you to kind of abstract away and have one config, and then it's going to be translated NetMiko, I think. I don't remember the names of the tools, but it's something that can be done, and we don't have to rewrite everything that we have right now, which is good.
The whole networking industry is sort of moving towards having a more uniform configuration language and API between devices. I mean, it's not there yet, but it's the direction everything is going in.
Yes, yes, exactly.
So from the automation, it looked like the route propagation was almost instantaneous.
Yes.
Which also means your blast radius is like super high in case you have something that gets missed in the validation while you're checking the config. Is there any sort of way, or like how would you try and do like a scattered deployment of a change? I don't know if that's possible.
Good question. It's instantaneous because
that's like the BGP.
Yeah, that's
property,
BGP. And for the thing that we use, we want it to be instantaneous. To achieve sort of partial change, we don't have this scenario implemented, but I guess we can do a couple of steps, a couple of similar steps, and apply it to multiple devices in different time. Or again, use automation and some sort of logic for that.
Yeah, this is a problem I've run across as well. And the BGP works by being in a converged, consistent state. So canarying it is sort of antithetical to the entire thing, right? I mean, I haven't done this myself. I think the answer has to be to try and simulate it. Maybe. Yeah. Are we possibly close to end of time. We can take maybe one more question.
So my question is more around the culture. In terms of getting your team onboarded and to follow this process, because you said nobody uses the CLI, but it's very tempting to use the CLI.
Yeah, it is.
So how did you guys work around getting people to fall into line with this process, that the automation tool should be the only thing that touches the network configuration? Was that difficult?
We have a very small team.
Yeah.
Very
okay.
small team. And we all participate in writing code. And we were not developers or software engineers before. And basically, because we all do it, we want to use it. And we all agreed that that's what we're going to do. So, and the rest of the SRE organization is, doing it too.
Yeah, so it is kind of, you have to have that will to want to do that.
Yes, we do.
Yeah.
We kind of force ourselves.
Absolutely. Cool.
Yeah.
Thank you.
Thank you.